So continuing on the 122 Mark III overhaul, I've spoken with the owner and we've decided to lap the record head on this. The repro head is in good condition, and so get this off. I will do this off camera. I've done a full lapping video. I'll link it here in a card. I've also got many hours of video to get through on this, or many hours of clips, and so I'll try to compress those down as much as I can into as short a video as I can, if possible. So if you don't like fast forwarding or it offends you, I don't know what to tell you. So clean this up. And get about lapping. Okay, here are the results under magnification. Turned out very nice. Again, this is just the record head. I don't see any reason for concern on here. It didn't. I didn't take very much off. It was just mainly straightening it back up. There's the other channel. Got one little scratch that didn't come out. I don't think it's wise to try to take any more off of this, so I'm going to leave that in. Right there. And I like I said, I don't think it's worth it to go back and take any more material off to get that tiny bit out. The rest of it looks excellent. And by way of comparison, this is a brand new head, same part number. I can't get as close magnification on this one because the guide is interfering with the microscope objective. So this is the next level down, but that's what the brand new head looks like. And just to show by comparison how I do lap them to a little bit finer, well, probably a lot finer finish than the factory does. This little bit of surface rust here is nothing to worry about. This is just from them not being used. And when I get these, I coat them with an anti-corrosive. Again, this is surface corrosion that will come right off with the tiniest bit of polish. But that's how they come in. That's what they look like brand new. So you can see the lapping marks are coarser on this than on mine. Okay, so that's done. This is the recap on the motor and cleaning and relubed. This is all ready to be put back together. The Hall sensors have been reseated, repotted in place. I have lubricated these sintered bronze bearings a couple of times with the PDP 65. I've let them sit overnight. I lubricate the bearings and clean the capstan. I don't lubricate the capstan. I put a tiny drop of Krytox down on that brass bearing right there, just for, this is almost just for shipping. This is for the few times that that will ever contact that bronze bearing. Like right now, it contacts it right this second, and then the magnet pulls it up, and that should be about the last time it contacts that. Other than, like I say, in shipping, or if it's moved around or impacted. Now put this back together. I might link another card to the full rebuild of the motor on these also. I didn't know this, but I can, YouTube only lets us put one card per video in another video. And so if I have two things I want to show, I can't do it. I can only pick one place to put it. Okay, I've made a brand new oil seal for the capstan shaft. I've copied a factory TIAC part and turned these out of a much stronger material than what they made them out of, and so that should be this should last a lot longer. And I'll just pull that back a little bit. This is the process I go through when I lubricate decks that are already serviced and assembled, whatever, but just pull that oil seal back a little bit, and I'll put another half a drop of the PDP 65 or 68, either one I think is okay on these, and then push the oil seal back. And really that should be good for, 6 months to a year of heavy use, maybe a year or two of moderate use. And that is ready to go. I'm going to do a little bit of polishing on these guides. This is, I think, 4,000, 3,000 or 4,000 grit, just on a piece of pegwood that's been shaped so I can get it in between those guides. I'm really just rounding over the little sharp edges and the top a little bit, and I'll be polishing these out. And I just polished out with a little bit of Jeweler's Rouge. I've had good success with this. Okay, I'm back together, soldered back up with the leads. And that head is ready to be reinstalled. Zoom in here a little bit. I've applied some glide coat on these already. That's why they're not quite as shiny. I put that on, let it sit for a few hours, and then just buff it off. Okay, we'll continue on. I like to clean these leaf switches also. This deck is one of the later ones, and it doesn't have a whole lot of wear on it, but I still think it's wise to just give a quick cleaning on these leaf switches. No doubt these are in good condition, but I've got them out and it's here, so I'll just give them a cleanup. I need to be really careful on these covers because they can easily break, and it only takes just a tiny amount of leverage to get them off. Okay, so I'll just put a contact cleaner on a piece of paper. This is evaporating. This doesn't leave any film behind. And that's it. Do that to each one. And then get back to the heads. This is what I showed in the last video, the gauge block stack that was placed in under that head block, just to give me a fast way to put it back into close position that it was removed. And this really helps when these are removed to put them back and not have to spend quite so much time aligning everything. I'm just doing this, I'm holding it this direction for the camera. It's a little bit harder for me to see what I'm doing, but the camera can see it, so that's what I'm trying to show. Get them down there, get them close, and try to keep them parallel with the gauge block. And I had a sliding fit when I took it off. Maybe just a little bit tighter than that. Not quite that tight. And it always amazes me how close this is to alignment when I do it this way. It's only takes a few seconds to get the azimuth set and the tilt and the height as well. I get the real motor put back together. This does not need to come off really for servicing this. I took it off in order to measure it so that I could at some point make a puller, because I know I'll need to get, these later models had a press fit shaft in there, and there's really no way to get that out without some kind of a puller, and there will be a time I'll have to have that or remove that, and so that's why I did that. This is not necessary. If the shaft needs work, or if the idler needs replacement, not the tire but the actual idler will, then that puller will come in handy. And so I'll just make that up and put it in the drawer and have it ready for when it's needed. This idler tire is not in bad shape at all. I do have one that I'm very happy with, a replacement that it's taken me quite a while to find these. And I sell these on eBay. Maybe I'll put a link in the description here, but I searched far and wide for nice idler tires for these. And these are actually, I like them better than the factory ones. These are some of the best ones I've ever found. Just a little bit of alcohol, clean that up. And just pop the new one on. On the ones that are removable, I would normally take that off and clean it and relube it with a little bit of moly coat. This one doesn't really require that, and it doesn't come off easily. And so what I'll do is I'll use a little bit of the moly coat just underneath the hub. And then on the arbor, just a little tiny drop of this pure dimethicone. And just on the arbor, run the gears dry. Oh, that needle's just a little too big. Let's do it this way. That's about all it needs right there. Reinstall the thrust spring, and then the rest of that pivot assembly will just slip right on there. Okay, we'll clean up this control cam PCB. I'll just start off with a little bit of brushing on the motor gear. It's clean, it's got a little debris on it. Again, I've lubricated the front bearing on this motor and let it sit and soak in overnight. Just alcohol there. And then I'll come back with contact cleaner. I like this stuff from Keg, the maker of deoxit. I'll just put a little cover on that to keep it clean until I reassemble. Same thing on the contacts. all these motor leads and switch leads on this series of decks, in fact on the Mark II as well, just as bad. They used a very thin lead and they didn't do the best soldering job on it, and so they tend to fray and break off quickly with just the slightest amount of use. And so my habit is to remove them and cut a new end and then resolder them with a little bit better technique than what they used. So let's get that done. I'm going to use a little flux to help me out. And those leads have their memory that are interfering. Now just remove all the old solder. And then I'll get the right length on these and clip off the old and make new. Besides being very thin gauge wire, I think the other reason they fray so easily and have so many problems is because they soldered this right up to the insulator, and that causes unnecessary strain. So by keeping the solder and the flux off of the insulator, about a wire diameter away from the insulator, it gives it a little bit of strain relief. And so that's the way I do it. I clean off any flux. Okay, so I've got unsoldered conductor up to the insulator there, and it really does help. I just twist a little loop in it with wire pliers. I see a lot of these where they put the conductor through the loop and then they twist it about a dozen times and soldered that on there, and that is just not necessary. That wire is going to fray a long time before that soldered loop ever gives way. That's it. You can see there's just about a wire diameter of free conductor there. Okay, anyway, that's my method. Same thing here. Basically do all the motors, and typically the mode switches are the other. This one's not too bad, but if they get much older, then those wires will fray too. I want to get the pinch roller off of here. It's glazed over, but I don't see any cracking or anything else. Again, this was one of the later models, later production model machines, and so Most of the components are actually in pretty good shape. See if my little anvil works, and no, it doesn't. Got to get a taller one. Okay, that fits. And the punch and the Warrington hammer. This is where a guy needs one more hand. There it is. I'll take this pinch roller down and clean it with warm soap, warm water, Dawn dish soap, and a soft brass and nylon brush. I'll start out with the nylon, see how it does, probably finish with brass, and then if it needs more from there, we'll take it to the precision grinder and reshape it. But I don't know. We'll see how it cleans up first. And it actually cleaned up beautifully. That pinch roller is just like brand new. All the chemicals, all the solutions, all the other things, nothing beats scrubbing it with a brush and soap and water. That's it. I want to test this capacitor. These are generally okay, but I want to test this one. And looks like maybe 1.5 ohms on that. And if I follow the chart over to the 47 microfarad, I see that it's right on the cusp of possibly too high. I'm going to change it. My only problem is the only one I have is a little bit larger size in that 105 degree. And so I'll have to check and make sure that I have clearance for this, but I would like to change it if I do have clearance. I expect I'll be okay here, but I just want to confirm it. It goes roughly about there. Goes roughly about there. Yeah, it's close, but I think I'll be okay. So yeah, I'll go ahead and change that out. This would have been a great place to fast forward, but for some reason I didn't do it. I will now. I notice those little leads there are kind of hanging out there wild, so while I'm in here I want to maybe add a little bit of epoxy and make sure those stay separated. Just to be on the safe side. Yeah, get our leads bent up here. Try to get the best fit I can on this. I realized that I misread that chart a little bit and that the resistance wasn't that bad on the other capacitor, but that's okay. This will ensure a good long life on this. Those pads cleaned up. I'll tin those. I'll tin the capacitor leads. That should work just fine. Okay, very good. Let's deal with these leads here quickly. Just clean the board up. I'll mix up some of the PCB epoxy. And just about one little tiny drop is all that we'll ever need. Okay, well that's setting up. The other thing I want to check here is the axial end play on the motor. I've checked these in the past. This one has about 10 thousandths. I know you're reading a little parallax there to the camera, but it's pretty close to 10 thousandths. And I wanted to check this one particularly because it's a untouched motor in terms of the adjustment screw on the back there. So I've checked a couple of these now that I believe to have been untouched, and it looks like 10 thousandths is the consistent run out or end play that I'm seeing on these. And so I'll be able to have a fair idea. You can see that paint lock is untouched on there. So this one hasn't been ever turned, it hasn't been adjusted, and I'm going with that 10 thousandths number on end play for these motors. Geared up. Okay, everything's clean, dry. Time to start putting things back together. Well, this is the cam gear, and I noticed when I removed it in the other video, you can see that it was pretty tight on that arbor, and it should not be. This should be free floating. And now that everything's clean, it's really tight. And that shouldn't be that way. And so this is something that we'll deal with here. I have, let me show you that. See, that should spin on there freely. And even though it was working, let me just say, one of the reasons it's tighter now than it was when I took it off, the lubricant for one thing, but the other thing is that the plastic will flow around a shaft like that. So let's get a measurement, see what we've got, and then we'll open that bore up to give it a little bit of clearance. Okay, so it's looking like to me like about 156 and maybe 5/10ths. 5/10 thousandths. So that bore should be somewhere around 157 and a half, 158, something like that. Here's a 156 pin, which is a 1/2 thousandth smaller. And you can see that that's about the size. So that bore is roughly a 1/2 thousandth interference fit, and it should not be. There's a 155, and it operates freely on that, and that's how it should operate. Let's see, 156. Not good. So this is not the factory cam gear. This is one of the replacements. And the way I know that, they look similar, but the way I know that is the replacements are also too small. And the reason for this is plastic shrinks, especially after the injection molding process. And the plastic shrinks up, and as it continues to age, it continues to shrink up. And of course, that's why all our tight-fitting shafts with plastic gears on them are all broken. These don't generally have a problem because they are not a press fit onto a steel shaft. But these are too small, and these are all too small. So I'll be aware of that if I ever do have to replace these, but you've seen me in the past. I don't typically replace these because I don't see problems with them. But in this case, this was replaced because it came from the distributor of these. And so he probably put the whole new gear train in it. And so just be aware if you do ever replace these, you'll have to open up the bores a little bit, at least so far, what I've experienced. All right, so let me dig around here and see what I have for reamers. And what I found was a brand new 158. And that should come pretty close. Again, reamers don't operate in plastic like they do in steel or metallic bores. It's very possible that the plastic will just flow around this reamer and not allow it to cut anything. But we'll try. I don't know. I don't see it cutting anything. Don't see any shavings on there. Maybe chuck it in a drill and try it like that. So the problem with this is the reason it was operating and still can operate with this level of interference is because you got that small gear on the motor driving a gear train and this bigger drill or this bigger gear, and it can do that. It can, but it's going to be operating a much higher current and it will wear the motor out much more quickly. So even though it does operate, it's not the right way to do it. That is slightly better, but not enough. I'll keep trying this for a minute. And of course, operate these slow so it doesn't melt the plastic. Really doesn't appear to be taking much material off. Okay, so my next size reamer is too large. So from this point, I'll have to try some drill bits. Again, a little better, but still not enough. and see if this one's any different or if it behaves exactly the same, and it behaves exactly the same. All right, I found a couple of twist drills. They're getting close to the size I need. Let's see if I have any luck with those. It can do the same thing. The plastic can flow away from these just as easily as a reamer. So this is just a matter of stepping up a little bit at a time. Not really anything happening there either. Calculating fits on plastic is an entirely different subject than doing it in metal parts. In metal parts, we can just look it up in a chart, in the handbook, and find out. But in plastic, there are a lot of parameters that have to be known. Data about the plastic and about the process and different things. And so it's a difficult thing. And it's a whole different engineering discipline than the type of work that's done in metals. So what I ended up with here is a number 19. The other two really didn't get me where I needed. And hopefully this one will just start to pull a little bit of material out of this bore. Got to tighten that up. Okay, it feels like it's cutting. Yep, there, got a little chip finally started. Okay, let's see what that does. Now all I did was just get it started. I didn't go all the way through. I'll go, if it does suit me, then I will go from both sides. I think that feels pretty good. Let's get started from this side, and then that kind of helps me know that I'm centered. So really, this is something to be aware of, anybody changing these out, if you feel the need to change them out. Let's see how that feels. Yeah, I think this will be okay. I'm sneaking up on it here because I don't want the bore to be oversized. That's removing a very tiny amount of material, but I think it'll be okay. I think it'll be about where I want it. Okay, it slips on there. That looks really good. Okay, that's where it should have been all along. Try to give the camera a good view on it. So that's quite a bit different than it was before. And that will save out that motor. See, there's no excess play there. A little bit of moly coat, and that will be perfect. Let's just see where we ended up. Kind of shooting for around 168. Or 158, I mean, sorry. Okay, so that's 158 right there. Let's see if it can slip through there. That's pretty much a 158 bore in that plastic. So that's giving me about 1/1000th and a half clearance. 157 just falls through. So just to illustrate the point, that number 19 drill I think is a 166, and that cut a 158 hole in that plastic. Okay, that should be good. And of course, the 156 will fall right through it. Okay, I think we're good. And then just for my own reference, this is what I'll do in the future with these if it ever comes up again. Okay, we'll just deburr this. Got just a little bit of an internal burr there. I clean that out. Can't hold on to it. Okay, I'm happy with that. And we'll deal with those later. And let's start assembly. Now for right now, I'm going to run the gear to gear train dry. I'll lube up the shafts and the bores, but I'll leave the actual gears themselves running dry. And I want to test all this out before I go back and possibly apply any lubricant. And this would be the correct lubricant on these gears. And of course do all the cam surfaces. And on this infamous C gear, I use these laser sintered ones that I buy from Germany. That's the one there on top. You can see a little bit of difference. And it's just a better product than the injection molded ones. It's also quieter is the other thing. Okay, I like all that. Okay, and I'll do my best to speed through this whole assembly process. I've done this before in detail. I should have said earlier, but if you want to skip through everything and just see the end results of the flutter tests and the way the tape tracks through and all that, it's almost at the end of the video. But of course I appreciate it when people watch the whole video, but if you don't want to, fast forward to the end. Okay, there's our happy little cam motor. We'll be much happier now. Now, of course, the real motor can be gotten to from the front by removing the cover plate there and these two screws if the idler needs to be replaced. Idler tire needs to be replaced. I found these nice little like pipe cleaners, and they're meant for, I can't remember, meant for shower heads or something like that. But I found these on Amazon, and they work great on these tiny bores. A little bit of IPA and then some air, and it just cleans out those bores beautifully. I bought a bunch in a whole lot of different sizes. Sorry, that's out of the frame there. I'm just lubricating the shafts for the reels with the same moly coat. And then just a tiny drop in there. And those little Delrin washers got placed back also. The retainer clips on the front. Now the grease that Tascam over applied on here had a real negative effect of kind of cutting through the plating and exposing the base metal. And so I can't just leave it like this. I don't want to put a bunch of grease on here, but I need to protect this from moisture vapor. And so in this case, even though I usually use the Moly coat on this, also I'm going to use Lubriplate 3000 because I'm aware of its ability to repel moisture. And you know, I have to do this. I have to cover up these base metal parts, even though I don't like the looks of it. I have to do it. I have to protect these from corrosion. And that will do the job. Even though it's not as pretty and as clean as the other. There's no choice on this. I can't replate these. This is excellent lube, by the way, and it's very similar to what they used early on. I don't know why they changed, but this will do the job. Now, in the ball bearings, I'll go back to the traditional damping grease because that's important on these. And I use the medium damping on these three lower ones and then heavy damping on the top one that holds the heads down. And this is important for vibration damping on these. Again, I'm actually applying more than I normally would as an anti-corrosive coating. I gotta make sure I get some back there too, because that plating also had worn off a little bit. Okay, that feels really nice. Okay, this is the heavy damping. Okay, that feels nice. Just want to make sure I don't have any debris stuck in there. Every once in a while something will work its way in, and it won't be smooth. And it has to be taken all apart again, cleaned and found, and so brakes look good on here. Again, another indicator of lack of wear. Brakes were in good shape. Most of these plastic parts I clean manually like this. I don't put them in the ultrasonic. They would probably be fine, but I just do it like this. Put a little fresh lube on the brake parts. Need to correct the position of those. There we go. Just a little bit of lubricant there where their actuator is. Time to put the motor back in. And I'll use a little bit of the gel blue Loctite on that thread so that the motor doesn't loosen up again. This is easily removable, but it will help that nut from loosening off. And this is nearly ready to test. Getting very close to it. Okay, operates correctly. We'll have to reset the head height and tilt because everything was removed after I did it the first time. You can see there's very little adjustment needed after using the gauge blocks to reposition the head stack. Just a little bit here. This is actually checking the race head after I had to do quite a bit of work on that to reposition it because it was out of alignment. The plastic housing and mount on these will shrink and it will move around, and it's really important to check that also, and I had to do quite a bit of work to get this one repositioned. But it's now aligned. Basically, that's the completed transport assembly. I will do a degauss on all the metal components that come in contact with the tape. Now, I like to fast forward through this, but I realize that that's probably not a smart place to fast forward, because it is important to move the degausser slowly. Let's check it. I check it because occasionally I see some magnetism, sometimes coming from the motors for whatever reason. And this one looks pretty good. That number 1 and 2 I'll show you here is just residual magnetism on the bench. That's not coming from the motor. That's just what it's picking up, ambient. Okay, let's get it installed and see how much damage we managed to do. Okay, so the first thing I'll do here is go back to the same homemade flutter tape I used in the first video in the evaluation. And more or less wind it back to the same place I was. And let's see how we did. Now the spec on these, the advertised spec is 0.04% flutter. And it's looking like I'm better than that, which I expect. This deck is not worn very much at all. And after a full service like that and dialing in all the different tolerances, I expect it to perform better than advertised spec. So that was a little drop out there, and it has to recalculate it. So I'm obviously more than pleased with that. Now in the evaluation video, I think I may have had my instrument set to flat rather than the RMS that I'm showing here. And that was at 0.15 and 0.16. So let's just redo this again on unweighted and see what kind of numbers we get. Okay, so 0.11, 0.12 compared to the 0.15 and 0.16 I was getting. So that's 50% better any way you look at it. We're very close to 50% better. Okay, so one more time on weighted, which is what most of us are used to looking at. Yeah, so it looks like it's peaking out at 0.04, which is the advertised spec, and it's kind of averaging maybe down in the 0.035 range. And I'm seeing it down in the 0.02 range a couple of times also. Okay, let's check the speed. If you remember, the speed was a little bit slow, by about the same amount, about 0.3% slow, and now it's 0.3% fast. And that's again to be expected with a full overhaul and fresh lubricant. So let's set the speed up correctly here. This is in the most ridiculous place I've ever seen a speed control. You have to remove that left rack here, and the two trim pots are behind that. Now when I replace this, I mill a slot in that rack here so that it doesn't have to be removed to change the speed. And the other part that I don't care for these is that they're so sensitive. It's a single turn trim pot. They could have put a 4-turn or a 25-turn and made it so much better, but they didn't. All right, so I've got that zeroed out. I'll put the pitch control at vertical or close to vertical, and then the lower trim pot is to set the pitch control, just so that they're fairly close to each other when you switch over from on to off. Again, they're just so touchy. I'll speed through this. Nobody wants to watch this part. Okay, so I'm good on that. Now let's put every time I do this, it works fine in the video, and then when I upload it to YouTube, it gets convoluted, and you can't really see the numbers. But I'll try it again. I've changed my frame rate that I'm recording on, so maybe this time it'll work. I won't know until I upload the video. But the upshot of it is I'm seeing about 45 on the take-up tension and about 8 on, about 8 on the back tension. So hopefully you can see it, but I don't know. And then finally, let's look at the travel. And this looks good to me. Run that through a few times. It doesn't even look like the guides are touching it on entry or exit, which is my goal. Okay, so I think I'll leave this one here and bring it back on the testing the final results of this deck. I'll do the recapping offline. I have other videos of doing recapping, and they really don't seem to generate a lot of interest. But I'll show the results of that and do one last video of the results. So once again, thank you for watching, and I appreciate all your comments. and anything else you have to say. Thank you.